Hello everyone, this is Keith Park with Print Your World. Today I'm going to be talking about materials, the materials that we print with, and some important things to note about them. Now, one of the things I want to talk about is hygroscopy. People are like, what? Yeah, it's an interesting word. Filament, 3D printing filament, many of them anyway, are hygroscopic, which means they absorb water from the air. In fact, when it comes off the roll at the factory, typically these rolls have got about 0.2% moisture inside of them, and in a 40% household, they can reach 1.2% humidity in very little time. Now, when you think about a 1% change in the volume of something that's a kilogram in size, well, that's a change. And there's not just in weight, but also the way that it affects the filament and how it prints. So I'm going to quickly show you that with an example I've got queued up here. And then I'm going to go and talk about the other printing materials that we work with. Now, first here is going to be, on my printer, I've got set up a example of a white filament that is not currently wet, and then I've got it followed up by a blue one that is. And you should see the difference when I do it. So I'm going to turn it around and start this on up here now, in a little patience, and you'll see it. So that's kind of what it's supposed to look like for the length. Now, if I start telling it to start loading up the blue filament, which I'm telling it to do right now, see, it starts pushing on out the white filament that's already in there. And we're going to get to the blue filament real quick here, and I want you to see what's happening. Do you see how fat that filament is becoming? That's because it's literally foaming as it's coming out of the nozzle. Alright, so I think that showed that example fairly well. Hopefully that was a good one, otherwise I might have to redo that video. But I think that shows it well. Now, what other things does this cause? Well, there are some issues that it does, for sure. So I'll give you an example. When we are going to go and print something, we wind up often finding that it will do little blobbing as it's going along, and then a consistent line, and then it seems to be flat. Well, all I can really tell you about that is that when the water is inside of the filament and it hits this really hot nozzle, it sort of steams. So it either fills out in a blob, or it gets applied down in a way that just doesn't look consistent or right. So how do we solve this? We solve this with filament dehydrators. Like, for instance, this one right up here. You can, however, go and use food dehydrators to go and do the same thing with a 5-gallon bucket on top. But now that's where we're going to start talking about the materials, because when you dry these materials, you have to bring them to their glass transition temperature for between 4 to 6 hours to be able to get them dry again after that. Now, the biggest offender out of these is definitely going to be PLA. Now, we use PLA a lot in the printing because it's a great prototyping material. It doesn't cost very much money. You can get it very cheap. And so anytime you're wanting to make something, it's a de facto standard to go and do. Now, when you are going to be making something that actually needs to be functional or take impact or be reused many times, this is when we start talking about PETG or ABS. Now, I'm not going to recommend ABS because it has a lot of volatile organic compounds. That means not good stuff to go and breathe, and also gives off a lot more particles than the other types. Now, noting that, when we go and consider this point here, PETG itself has a lot of the strength characteristics that you see with ABS, and it prints very, very interesting. It, when you buy no fans, is really strong, but doesn't have great detail. When you use up to 30% of stock fans of most printers, you can get some great bridging happening, which means you can make really long areas of where the filament actually goes across and forms a bridge at the right speed with the right fans. And temperature. So these different things affect how PETG prints. Other printing filaments, they tend to remain fairly consistent as what they do at different temperatures, but PETG becomes a lot stringier when it gets hot. Now, those are your two main ones that you're going to use. There are some others you can play with on out there. There's nylon, which has got great flexibility. You've got POM. POM's hard to print with, but it's great for food safe perspective because it doesn't absorb water or anything else to that respect, and you can sanitize it without worrying about running it in the dishwasher. I have done this a number of times just to verify it. I'll say the same thing about PETG too, because these are not reaching the glass transition temperature. If you put a PLA object in the dishwasher, it's not going to be so successful. You'll find it has a tendency to go and melt. That's because the glass transition temperature of PLA is somewhere between 55 and 60 degrees Celsius. That's not where it melts. That's not where it achieves a liquid state. That's where it begins to be malleable and can be deformed. PETG, on the other hand, is somewhere between 70 to 80 degrees Celsius, and when you're dealing with ABS, that's 100 or more degrees Celsius before it starts deforming. So, depending upon what your usage is, it will really change what material you're going to use. Now, we also have support materials out there, like PVA, polyvinyl alcohol, and HIPS, which HIPS is used with ABS and PVA is used with PLA. And these are great because they're called dissolvable supports. There are water with the PVA or a chemical called dilimone, which can go and dissolve the supports of HIPS. So using that allows you to be able to create some shapes or objects you otherwise could not normally print because you can't remove the supports from, say, the inside of a structure. So that's how those would be used. Now, you know what? Material science is a really wild thing. And understanding how your materials work will often go and improve your prints just by understanding, okay, I need a little bit more temperature here. Or, hey, why didn't that stick to the bed? I had it way too hot. I went way past the glass transition temperature. Or, why isn't it sticking? Oh, I didn't quite have the glass transition temperature. Now, I want to add another caveat about PETG real quick here. I have seen it eat the glass of glass beds. So, it's not that it doesn't happen. It is unusual, however. So, what do people do to go and prevent this? We use what's called an interface layer, and that's usually where we'll use glue stick, or we'll use blue painter's tape, or a number of other materials that act as a barrier between the glass and the PETG, so that the PETG doesn't go and too deeply sink itself into the bed when you try to go and remove it, tearing out chunks. So, there are a lot of different aspects of the printing process associated with the materials that can be fine-tuned. And if you have any questions about that, I really would like you to go and follow that up in the comments here and ask about those questions. And, if you liked this video, definitely like it and subscribe to my channel because I've got so many more videos like this coming in the future. Thanks for your time, everyone. Have a great day.